Dear students, let us continue the module 3. In this video, we are going to study the race condition. This topic comes under the third chapter, which is process control, and the race condition is here. What is race condition? So see, basically a multiple of processes when they runs and they try to access any shared resource or any shared data, then which process can get access to the resource or shared data, that is not predictable by user. So this is called the race condition. So I'll go with the line. A race condition occurs when multiple processes are trying to do something with shared data. More than one processes trying to do something to a shared data, then that is called the race condition. And the final, one more condition is there in that the final outcome depends on the order in which the processes run. The final outcome, which process will access or modify the shared data, that is not predictable. That depends on how the processes are running. So in general, we cannot predict which process run first. We cannot predict which process will run first. Even if we know which process would run first, what happens after that process starts running depends on system load and kernel scheduling algorithm. Even by putting some condition, if you know which process will run first, then also the final output means which process will access the data. It depends on the system load and kernel scheduling algorithm. So let us study this with one example. Example here, the program below outputs two strings, one from the child and one from the parent. So here in the below program, we will discuss. Here the output is one output is coming from the parent process, another output is coming from the child process. Okay, the program contains a race condition because the output depends on order in which the processes are run by the kernel and for how long each process. So whether the output will come from the parent process or it will come from the child process, it depends on the uh, processor, system load and scheduling algorithm. So here in this program, the race is happening between the parent process and child process to output the data. Here we will define hash include apue.h, means some header files are there. Then static void char at a time, char at a time, char star. It is a prototype function. Its parameter is pointer, which holds the address of character. So integer main, we are defining a variable PID of a PID underscore t type. Now we are creating a child process using the for function, and what it will return will assign with the PID. If PID value is less than 0, if fork is returning negative value, means child process has not been generated, and it will send a error message. Error underscore sys fork error, means there is some error in fork. Else if, so as we know that fork returns two values. One value one value that is 0, it gives to the child process, and process ID of the child process will be given to the parent process. So else if PID equal to 0, when the PID equal to 0, so for the child process, so we will make a calling function of the function prototype, that is char at a time. So output is output from the child process. Else else char at a time output from the parent process. Exit 0. Now we can write a defined function called of this function prototype here. Char at a time char star char star str, a defined function is there, because here we are sending one parameter also, that is a string. Now char star ptr, one pointer also we have defined here, integer c. Set buffer std out null, that standard output we are making it null, means we are clearing the output buffer. Now for ptr equal to str, here atf, so pointer will start from the string and c equal to star ptr plus plus. So that pointer will keep incrementing, and whichever it will represent, that value it will be assigned with the character c. Int c is not equal to 0. If it is not equal to 0, it will keep on working, and the third parameter is nothing. Then put c. In that case, put c output. We are putting the c to the output string. So now you can see that that both we can run parallelly. So this condition is also true and this condition is also true, because here fork is returning two values, PID equal to 0 also it is returning, and PID greater than 0 value also it is returning. So this will be executed by the child process, and this part will be executed by parent process. So there will be a race condition between the parent process and child process to output this data. Now if we execute a dot out, so sometimes output can come output from child process and output from parent process. And second time if we are executing, you can see that output from child process and output from parent process. Third time again output from child process and output from parent process. So it depends on the system load, processor and kernel scheduling algorithm. How to avoid the race condition? The same program once again we will write here. Prototype char at a time char star integer main PID underscore t PID, and a tail wait function will call, and if PID is less than 0, your child process we are creating, then error is fork error. So if fork is returning less than 0, so we can generate a error message will be set. Else if PID equal to 0, that is the child process, wait parent. For will make the child process to wait for the parent. We are calling a wait parent function. Char at a time output from the child. Else for the parent process, directly we are calling char at a time output from parent. Output from parent, and we are, once this is output from parent, then it will notify the child process using the tell child function PID, and exit 0 static void. And we are defining the same thing, function we will call char at a time char star ptr integer c, set buffer std out null, and ptr equal to str and c equal to star ptr plus plus is not equal to 0, put c std out. So when we run this program, the output is as we expected. There is no intermixing of output from the two process. So here output we can get first output we can get from the parent process, and then we can get the from the child process. So this is all about the race condition. So in the next video we will be